Hello, and this time we're looking at simplifying indices. Now, I call this simplifying indices because very often in an exam you'll be given numbers with powers. So if you're not sure, indices is the plural of index, and index is the same as saying the power. And often you're not asked to actually work this out. You just get your calculator and just be like, well, what is... Oh, hang on. 5 to the power of 4. Oh, it's on a bit of a go slow this morning. 5 to the power of 3 over 5 squared times 5 to the power of 3. And you can just work it out. I mean, yeah, you could do that manually, really. The 5 to the 3, I suppose. And then you've got 5 to the 4. 625 divided by 25, and the answer is 25. But often you're not asked to do that. You've got to read the question carefully. Does it say calculate the answer, or does it say simplify into a single number with a power? And so we're going to look at the rules that we're going to apply to these. And then often what you also get is sort of algebraic questions, like, x squared times x to the 4 over x to the 7 or something like that. And of course you can't work that out as an answer, numerical answer, because you don't know what x is. So you can only simplify it. But I think I've addressed that in a different video. So when you've got these, just read the question very, very carefully. Does it want the actual answer, or does it want the simplified 5 to the power of something? Anyway, let's have a look at how it works. There are 3 ways you can simplify your indices. Okay, so if you have a number to a power and you times by the same number but to another power, or the same power I suppose, it's the same as if you did that one number, so 5 in this case, that one number to the power of the 2 indices added together. Okay, and you can see that this must be true if you have sort of a squared times a cubed. Then a squared is a times a cubed is a times a times a, and if we're timesing them together, well then you can't tell the difference. That times is no different to that times or that times. So there's 1, 2, 3, 4, 5 of them times, which is the same as just adding the powers together. And in the sort of opposite sort of way, if you divide them, if you say a to the m divided by a to the n, okay, or you could write it out as a to the m divided by a to the n, that's also fine. When you are dividing these same numbers with different powers, then you are doing the same as that number, but the powers subtracted. And again, you can see that if we do our a squared over a cubed, then this is a times a over a times a times a. And in this case, you're just saying, oh, well, a divided by a divides away, it sort of equals 1. A divided by a cancels, so we're left with 1 over a, or a to the minus 1. And 2 minus 3 is indeed a to the minus 1. So it works out logically in that way as well. And then finally what you can do is you can, like down here, you can raise a number to a power and then to another power. So if you do that, a to, and then raise to the power of n, and that's the same as a to the m times n. And again, you can see that because if you do a squared cubed, well, what you're cubing is a squared, so that's a squared times a squared times a squared. You could do it 3 times because it's cubed. And we've already said that when you times things together, you can add them up. 2 plus 2 plus 2 is indeed 6, which is the same as timesing them together. So hopefully you can see that those are relatively straightforward little rules, and it's just a question of doing these examples then. So we could look at this first one, just say, well, look, 5 cubed divided by 5 cubed. There's no point making the numbers bigger and then smaller again. That 5 cubed and 5 cubed are just going to cancel. So 5 to the 4 divided by 5 squared, it's the dividing one, so we're going to subtract the powers and get 5 to the power of 4 take 2, 5 squared. In this one, we've got 8 on its own, but we know that that's 8 to the power of 1. So we'll put those 1's in. And when we times it all together, we're adding the power. So 1, 1, and 2 is 8 to the power of 4 over 8 to the power of 5. And if we subtract those powers, we get 8 to the power of minus 1. And it's absolutely fine to leave it like that. You might, if you do have access to the answers to the questions you're doing, it might give you the answer as 1 over 8. And what, how the questions asked you to show it. If it says as a number to a power, well then actually 8 to the minus 1 is the correct way to do it. Okay, and then if you raise a number to a power and then to another power, you multiply the powers together. 2 times minus 3, it's 5 to the minus 6. And here you're raising to the power of 2, and then raising to the power of minus 3, and then raising to another power. Well, we just keep timesing them together. So 7 squared to the minus 3 to the positive 4. 2 times 3 is 6, times 4 is 24, and it's a minus because of that one. So it's 7 to the minus 24. Now, if you think that's very large, then it's not actually at all. If you did the bracket, if the brackets weren't there, so I'm just going to get rid of these. So this is a little aside. You won't really see this until you're past GCSE. But just so that you're aware, those brackets are really, really important. Because if you say you've got 7 squared to the minus 3 to the 4 without the brackets, then rather than sort of doing the 7 squared and then sort of negative cubing that, if you like, then what you should do if there's no brackets is you should do this first. So minus 3 to the power of 4, so I'm pretty sure that's going to be 81. And then 2 to the power of 81, well actually that's getting ridiculous then, isn't it? So let's have a go at that. Let's just check that I'm right. Bracket minus 3, because otherwise it won't raise the minus to the power of 4 is indeed 81, and then 2 to the power of that answer is 2.417851639, blah, 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 keeps going forever, well, not forever, but for a long time, times 10 to the 24. So that is basically 2, 4, 0, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21, 22, 23, 24. So you can, I hope, see that 7 to the power of positive 24 and then 23 zeros is a much bigger number than, even if it didn't have the minus on it, 7 to the power of 24, that power is tiny compared to 24. What even is this? 3, 3. So that's a billion there. 3, 3, 3. So, and what's that? So 2.4 million billion. Okay, quite a lot bigger than that. So yeah, those brackets are really important because that makes the powers simplify by just timing them together. No brackets, then you're supposed to work from the top, and then you get these ginormous powers, which are absolutely crazy. Okay, I will leave it there, and if you have any questions or comments, then you can leave them down below. Otherwise, cheerio.